In this next problem, it reads that we are going to, or that we know that point is moving along a curve, y equals x squared. We can draw a picture of that. It's really not necessary, but I will. So that dx over dt is 2 meters per second. We're supposed to find dy over dt when x is 3. This is flat out just right here for us. We know exactly what we are given and what we're supposed to find. We are given that dx over dt is equal to 2 meters per second. And we're supposed to find dy over dt when x is 3. Our formula is just our equation. We're going to take the derivative of that. The derivative of y with respect to time would be dy over dt equals 2x dx over dt. Plug in our known values. Well, we're supposed to find dy over dt. We have our x is 3, and we have our dx over dt is 2. So we end up getting 12, and we don't, oh yes, we do have a label. It's meters per second. That is our dy over dt. This one was pretty simple. The next one, it talks about the length of a rectangle is increasing. So I'm going to not even finish reading the problem. I'm going to draw my rectangle. So the length is increasing at 6 feet per minute while its width is decreasing. Decreasing means I'm going to have to put a negative in front of there, so I'm going to go ahead and do that right now. Find the rate of change of the area when the length is 100 and the width is 30. So I was given a couple things. I was given that the length is changing, dl over dt, is changing at 6 feet per minute. And I was also given that the width was decreasing at 4 foot per minute. We are supposed to find the rate at which, oh goodness, sorry about that. The rate at which the area is changing. So find dA over dt when the length is 100 and the width is 30. Well, what is the area of a rectangle? Well, it's length times width. Well, I can take the derivative of this with respect to time. dA over dt is equal to, I have a product rule, must be careful. So first and second here, I've got the first term times the derivative of the second, which would be dw over dt, plus the second times the derivative of the first, which would be dl over dt. I'm finding dA over dt. I'm supposed to find that when L is 100, so I'm going to plug in 100. I know dW over dt was -4, plus I'm supposed to find this area changing when W is 30, and I know dL over dt is 6. So dA over dt ends up being -400 plus 180. Well, that's -220. Area is described as square units. So in this case, square feet. And the time is every minute. So the area is actually decreasing at 220 feet squared per minute in this problem.